So welcome to this class. In this session, we are going to give examples on how to solve problems involving hyperbolas. So the first question is to discuss the graph x squared over 16 minus y squared over 9 equals to 1. So when you say discuss, it means that now we identify the vertices, coordinates of the vertices, foci, eccentricity, and then explain the orientation of the graph, and then finally sketch the graph of the given equation. So that's what it entails about the term discuss. So solution. We say this equation can be written as x squared over 4 squared minus y squared over 3 squared equals to 1. And you see this one is taking the structure x squared over a squared minus y squared over b squared equals to 1. And as we saw in the first case, which is this hyperbola of this form, this is a hyperbola with center 0, 0, and then transverse axis the x-axis. So therefore, the hyperbola that we have, or the graph that we have, is of this form. We expect it to take this this form. So the first thing is to identify our A, which is 4, and B, which is 3. And know that B squared equals to C squared minus A squared, which tells us that C squared is given by A squared plus B squared. For this case, we'll have 4 squared plus B squared, which is 3 squared. And then C squared equals to 16 plus 9, which is 25, which means that C is 5. And remember, C are the number of units from the center to the foci, and A are the number of units from the center to the vertex. So therefore, because we have known that this must be the structure of the graph given in the question, then you know that at this point, this way will have, say, your V2, this your F2, V1, F1. So coordinates of the vertices. So V1 is given by A, 0, which will be V1 has coordinates A, which is 4, 0. V2 is minus A, 0, which means V2 is minus 4, 0. And then foci, F1 will be given by C, 0, which will be F1 is 5, 0, and F2 is minus C, 0, which means F2 is minus 5, 0. And then we have also discussed how to find the asymptotes. So asymptotes, when this is the structure of the graph, we say that they're given by y equals to plus or minus b over a x. So they'll be given by y equals to plus or minus. Our b is 3. Our a is 4. So this will be the equations of the asymptotes. And therefore, we have all the information that can help us to sketch the graph. So we draw the y-axis. This is the x-axis. So assuming this is our where we have the point -4, and then this is the point where we have +4. So we expect to have our asymptotes to be this line. So this will be y equals to 3/4x, and then this is the line, y equals to -3/4x, and then this are the arms of our hyperbola. So this is what we have. So this is the graph. So these are the sketch to say that we have 5 here, we have F2 or F1, and then we'll have -5,0 here, to the point we have a F2. So this is our V2, this is our V1. So this is the graph of the equation given. And then you can even go further and give the eccentricity, which is given by C/A, and C for this case is 5, A, which is given by 4. So 5/4 is 1.25. So that's the eccentricity for this given hyperbola. And you can even say the length of latus rectum are given by, so 2b² will be 2, b was 3², and then over a, which is 4. Then you simplify. So that's what we can do on that discussion problem given in the question. So the next session, we're also giving more examples on hyperbolas.